and welcome to this video. In this video I will be showing you how to set up opencv-dnn module with CUDA backend support. Basically we will be building opencv from source with CUDA backend support, enabling the opencv-dnn-cuda module. That makes the inference much faster for object detection models as compared to the opencv without CUDA backend support. We install that using the Windows installer. This will be built from source, so let's get started. There are 6 steps for this. The first 4 steps are basically just installing the required software. If you watched my previous videos and have been following my tutorials, so you'll probably already have these software installed, but just in case I've mentioned them over here as well. So first is install cuDNN on your Windows system. This is for Windows. I'll be making another tutorial for Linux in my next video. Okay, so you can read more about this cuDNN installation process over here. You have this for both Windows and Linux, so you can follow this tutorial and install cuDNN, download CUDA, install it, set the environment variable paths, do the same for cuDNN. Now one thing I have to tell you, you have to make sure that you add these path variables to both cuDNN and the path system variable, as we will be using CMake in this tutorial. I found that CMake, sometimes a few versions of CMake cannot locate this cuDNN variable, environment variable, so it's a better option to include all these in the path variable as well. That ensures that it will find the cuDNN on your system. Okay, I've also mentioned this over here. Alright, moving on to the next step. Install CMake GUI. Just download it from over here and select your version. I have 64-bit Windows, so I have already installed this on my system. Now when you're installing this, make sure to select add CMake to the system path option for current user. Set the destination folder, and that's it. Now third step, install Anaconda individual edition for Windows. You can download it from over here. Now when you run the setup for Anaconda, I want you to select this just me option. This is also the recommended option. This is just to avoid any permission errors in future. Alright, so I've mentioned this over here as well. I already have Anaconda installed on my system, so I'll just show you the next step. You have to check both these options. Register Anaconda 3 as my default Python 3.9 and add Anaconda 3 to my path environment variable. Check both these options and click on install, and that is it. Now next, install MSVC, Microsoft Visual Studio. You can download the community edition from over here, and in there you can select this module. Once you run the setup, desktop development with C++, this is the one that we require. Of course you can also add a few other modules later on, like Python development and a few other modules. Make sure all these are checked, and now we can move on to the next step. That is step 5, create a virtual environment in Anaconda. Now I'm creating a virtual environment as I'll be building the opencv from source for the opencv-dnn-cuda module in a virtual environment. It's a better option to do that for a virtual environment than for your base environment. I'd recommend you to do that as well. So if you want to install it for your base environment, you can skip this step. Alright, you can skip this step and move on to step 6, but I'll be creating the Anaconda environment. Let's create a virtual environment using this command. You can change the name to whatever you want. I'm naming to opencv-dnn-cuda, and I'm setting Python to 3.9. Yes. Activate the environment using this. Next we have to install NumPy for this environment, as we will be needing this in the CMake GUI that we will be running later on. Okay, so this is done. Now we can move on to the next step. Final step of this is build OpenCV from source with CUDA backend support for your specific NVIDIA GPU. Now I'll explain what this means later on. First, download OpenCV and OpenCV contrib. These files from over here, I've given both these links over here. The latest OpenCV version as of now is 4.5.5. Now you have to make sure both these versions are same. This is important. So as you can see at the releases site for OpenCV, the latest one is OpenCV 4.5.5, and we have to download this sources file, zip file. Now normally if you are installing OpenCV without CUDA backend, you just use this Windows installer for installing OpenCV. But right now we are building from source, and we'll be adding a few additional libraries and enabling a few other modules as I've mentioned earlier. So okay, that's done. Now next, download OpenCV contrib. Okay, you can download it from over here. So this is the latest version 4.5.5, but you can also just change this from over here. You can select the version from over here and make sure that it is the exact same version as the OpenCV source file. Okay, that's done. Now create a new folder in your C drive named OpenCV. Extract and copy the folders inside the master folders to the OpenCV folder. Okay, let's do that. Let's create a new folder named OpenCV. You can extract this over here, copy the folder inside. Now you can also rename this OpenCV and simply paste it over here, but I am doing this so it is easy to differentiate if you have multiple OpenCV directories on your system, so it's just easier. Alright, moving on. Now I've also given these paths in this tutorial, so you'll have to change these if you use a different directory. Alright, now create another folder named build inside OpenCV. Okay, let's create another folder. Now I'm doing this since we'll be installing all the necessary libraries and files over here. We'll be building everything in this folder, and later on we can delete this OpenCV 4.5.5 folder. And also we have to extract the other folder, as I mentioned over here. Extract and copy both the folders, these two. Let's also extract this and copy it to the OpenCV folder. Alright, now we can open the CMake GUI. Now we have to select the source as OpenCV 4.5.5, this folder over here. give this path, or you can simply browse it. That's it. Now for this we'll give the destination as the build folder. This one, that is it. Make sure the grouped box is checked, and that is it. We can click on configure. Now since I have Visual Studio 2017, I'll leave it as it is. You can choose your version over here. Next, select your optional platform for generator. So I'll be using x64. Click on finish. This will configure the settings for you for opencv. This is a warning for Python 2. I don't have Python 2 on my system, so you can ignore this. As long as there are no errors, it's fine. Okay, so it found the base environment Python file and the lib file. We'll change that as well for the virtual environment. Okay, that's done. So after the first configuration is done, this is the output that you will see. So the opencv modules to be built, we'll have Python 3 over here. Alright, now these are the Python bindings that it found. For the base environment, we'll be changing this to the virtual environment. As I mentioned earlier, I am creating this opencv module in a virtual environment. So alright, this is the location that it will be installed to, opencv build install folder. Now next step, we are done with this step. Now once the first configuration is done, select the following modules by tapping them in the search box and ticking their boxes. You can quickly copy them from over here. Now check this. Now some of these are already checked, but you have to double check these as these are important. This is already checked. This is for opencv-dnn and then opencv python 3. This one is also checked by default, but just make sure. Okay, now next we have to set the path to the modules folder. Click over here and then give the path to this modules folder inside opencv contrib, and that is it. Press enter. Now again, you have to do this step only if you are building opencv for the virtual environment, which we created in step 5. If you're not doing it for a virtual environment, that is if you're doing it for a base environment, you can directly skip to step 6i over here. But since I'm building it for virtual environment, I'll be running this step. Okay, so search these again in the search box. Now we have to set the path for these to point to the virtual environment, which is over here. The location up till here Anaconda 3 is the same. Then you have to go inside the environments folder. Over here we have the environment that we created. Okay, and then inside this we'll have the python.exe file over here. So just copy the path to this. In fact, since I know this is the only change in the path, so okay, as you can see it is already showing me the Python file. Click on it. Okay, again I'll just copy this. Now alright, we have the Python 3 include directory. This one, okay, just paste it over here as well. That's it. The same for the Python 3 library. Python 3 numpy include directory. And finally Python 3 packages path. You can also browse the folder from over here. Alright, but since I already know and I've done it previously, so alright, we're done with this step. Now we can finally move on to the next step, 6i, and click on configure. Now this will detect the CUDA and cuDNN on my system. Since I have selected these packages with CUDA, I've also selected this package opencv-dnn-cuda. I'll be enabling this module. This is very important. So alright, let's look at the output. Now this configuration takes a while, so just be patient. Alright, so as you can see, it has already found the cuDNN on my system. It has also found the version of it. I have 8.2.2 installed for CUDA 11.4. CUDA detected 11.4. Okay, so that's done. Let's look at the changes. I will see few changes over here for the Anaconda virtual environment that we created. Alright, so we have the cuDNN, the CUDA over here. Now as you can see, this detects all these architectures over here. We have to set this for our particular NVIDIA GPU. Now next step, you have to select this again, search, check the box. Now next, as I mentioned just now, that we have to set this for our GPU. You can find the architecture for your GPU over here. Now I have a GeForce enabled GPU and it is 1070 GTX 1070, this one, so it is 6.1 for my GPU. this is how you find the compute capability, which is also the CUDA architecture bin. Okay, so set this as 6.1, search this, you can remove all these and simply set the one for your GPU, and that's it. Now next, find CMake configuration types. Remove the debug option and set it for release, and that is it. We can just click on configure one last time, and then we'll generate the project with these settings. Okay, so as you can see, now we have our particular architecture compute capability set in this OpenCV settings. Alright, so just before clicking on generate, just double check everything. Everything seems fine over here. The libraries, it only takes for the base environment, so you don't have to worry about that. These are the main ones that we need for the virtual environment: the interpreter, the numpy directory, and the install path. Alright, and also the Python that we set, python.exe, for our virtual environment, and that is it. Now okay, it has set the architecture for my GPU and everything seems good. Now we can click on generate. Okay, this generates the project with these settings, which you can use to build our OpenCV. Now once the generating is done, you can either open this project in Visual Studio and build it over there using build solution, or I'll show you an easier option, an easier method to do that. Just open a command prompt and we'll enter this command and it will install the OpenCV for you. Okay, so generating done. Now we don't have to open this project in Visual Studio, you can do that, but now I'm going to show you an easier option, as I said. Now open the command prompt and just enter this command, press enter, and that is it. This will build the OpenCV for you. Now this will take a while. This can take up to an hour or so. So you can just sit back and relax and come back to it once it's done. Okay, so that's done. Finally, it took around an hour and a half. So we're done with this using this command. Again, as I mentioned earlier, we could have also done it the other way, using Visual Studio, just to open it and you can build a solution over there. We can close this, and now we have built the OpenCV in this installed folder over here. This is what we require. Okay, and we can now delete these, as we already have these modules and other libraries already inside this build folder. So moving on to the next step, last we have to set the following paths in your environment variables and reboot your system. So we have to set these paths. Let's open the environment variable. First we need this one, OpenCV build install x64. Basically we need the path to this and this, so you can just copy it from here. In your system variables you can create a new system variable with this name. Make sure the spelling is correct. Alright, and can paste one over here. The next was for library lib, and then for the build folder okay, so you can see we have added these three paths. I also want you to add this one path bin inside the path variable. And that's it. Click on OK. Now we have successfully built the opencv-dnn-cuda module, that is opencv with CUDA backend. After adding the parts we have to reboot the system. Alright, for the parts to take effect, let's do that. Okay, I have rebooted the system. So now these new paths are set for the environment variables. Okay, next you can run this to check the version of the opencv installed. So that will confirm if the opencv was installed or not. Now to confirm if the opencv installed was set up correctly with CUDA backend support, you can use this script. You can download it from here. I already have this script on my desktop. Basically it will give you outputs for two different scenarios. One is using GPU, that is CUDA using GPU, and the other will be for CPU. This will be slower, so let's run it. Okay, so as you can see, for GPU, for CUDA using GPU, it was done in 0.53 seconds, and for CPU it was almost 4 times that, around 2 seconds. So this has confirmed that our opencv was installed properly, the opencv module with CUDA backend. So alright, that was it for this video on how to build opencv from source with CUDA backend support. To enable the opencv dnn-cuda module on Windows, you can head over to this article and read this. I've written everything here in much more detail, so if you have any doubts or issues, just refer to this and you'll be fine. And okay, that's it for now. If you've enjoyed this video, please click on the like button and make sure to subscribe to this channel. And alright, I'll see you in the next one.